Okay, let's do a circuit in parallel. Let's say we've got, I don't know, a 20-volt battery. Let's go with 3 ohms and 2 ohms. We want to find all the same stuff: the current through each resistor, the voltage drop through each resistor, and the power emitted by each resistor. Okay, so we start by saying, I've got some current, let's call it I1 right here. Right here I have a junction. My current has to make a choice. Some of it's going to go this way, we'll call that I2. Some of it's going to go this way, we'll call that I3. So I2 comes around, we're still I2 over here, I3 comes over, those join back together, back into I1, so this is back at I1 again. So at that junction right there, the current into the junction must equal the current out. Now, this isn't going to be an issue in this problem, but sometimes we draw a circuit and we're like, wait a minute, how do I know my current is flowing this way? Maybe a bunch of current flows here and some of it flows backwards. Maybe I2 actually flowed the other way. The math takes care of itself. At the end of the day, if you solve this system of equations and you get a negative number for I2, all that means is you drew your arrow the wrong way, and it's really positive going the other direction. So it takes care of itself. If you draw your current flowing the wrong direction, it will take care of itself just by telling you at the end, oh, that's negative, and you realize, oh, I just drew my picture a little wrong. I probably still got the right number. Okay, so there's my junction rule. We have 3 unknowns we have to find. So we're going to need 3 equations total. Now I'm going to use my loop rule. I can draw any closed loop. So I could say draw this loop. Let's call that loop number 1. I could also draw this loop, or I could draw a loop that goes all the way around. You always end up with a redundant set of equations here. I've got 3 unknowns. There are 4 possible equations I could write out, one of which is unnecessary. So sometimes you don't know which loop to use until you write a few out and you're like, oh, well, it'd be easier if I did this loop instead of that. All right, so let's start with this loop. So going around this loop, I'm going through the battery the correct way. So through loop 1, the sum of the voltages. Going through the battery the correct way would be a 20-volt rise. Going around the first resistor that this loop passes through, notice my loop is going down and my current is going down. Let me clarify something I said earlier. If you go through a resistor, if your loop and your current go in the same direction, then this is a drop. If you go through a resistor one direction with your loop, but the other way with your current, if your current and your loop are fighting each other, then our convention here is to call that a voltage rise. Okay, so I'm going, this loop that I've drawn goes down through that resistor. The current I drew also goes down through the resistor. When things line up, it's a drop. So the drop through that resistor, V equals IR, -3 I3. That should equal 0. That's every voltage rise or drop around that loop. Now we need a second loop. I've got 3 unknowns and only 2 equations. So I don't know, let's use this loop here. Call that loop number 2. Then around this loop, I don't have any batteries, but I do go through 2 resistors. My loop is going down through that resistor. My current, I2, is going down. That's a drop. -2 I2. Over here, my loop is going upwards, but my current, I said, was down. Anytime you're fighting against your loop, if the current and the loop go in opposite directions, you go up through a resistor. So +3 I3, I times R. The resistor was 2, the resistor was 3. It's where the 2 and 3 came from. That must equal 0. Okay, questions at all so far?
Why is it, oh, it's -2 I2 because it's a drop?
Yep. If you go through a resistor the right way, it's a drop. If you fight the resistor, it's a rise.
Okay.
Going through a battery the right way, your loop going through the battery the right way is a rise. Your loop going backwards is a drop.
Got it.
Okay, so now we have this system of 3 equations that we could solve. Well, this one's easy because here I've only got 1 unknown there. I don't have to set up a matrix. I don't have to do a whole bunch of substitutions. This one's not too bad. I can just solve that. Get I3 is, what is that, 20/3? 20/3 amps. Plug that in here. To solve for I2, so we can just do a couple of back substitutions. So -2 I2 plus 20/3 times 3 would be 20 equals 0. Move the 20 over and divide. I2 equals 10 amps. I1 then will be 20/3 plus 10. So let's see, that's 30/3, 50/3 amps. You guys check my arithmetic here. Okay, then we can fill out our table. I'm going to write these all on top so I don't lose them. It's okay to approximate these, by the way. Throw them in your calculator on the test. I tend to like to work with fractions. 10 amps. 3 was 20/3 amps. Okay, now we're going to fill out our table. So we only had 2 resistors here. So our 3 ohm and our 2 ohm. We want to find V, I, and P through each one. So through the 3 ohm resistor, I had I3. That was 20/3. Through the 2 ohm, I have to go back and look at my picture here. I had I2. He was a 10 amp. V equals IR. So multiply V and I together, or multiply I and R together to get V. So 20/3 times 3 would be a 20-volt potential drop. 20 times 10 would also be a 20-volt. That shouldn't surprise us. In parallel, everybody gets the same voltage. We have two resistors in parallel here. I have a 20-volt battery. Everybody gets 20 volts. You split the current in parallel. You split the voltage in series. And then we find our power, we just multiply across. That would be what? 400 over 3 watts and 200 watts.